All right, so here I've got the 3D printed part that I showed on the forum last night. I printed that up real quick just to see if the geometry would work. It looks like it does, but you know, there's a couple problems. So first of all, let me just zoom out here so you can see what we're dealing with. I don't know if you can see that because everything's gray and black, but basically the way this works is that this angle right here, from here to here, right, that angle is 10 degrees, and then this angle comes back 10 degrees. So this angle here is 10 degrees going this way, and this one's obviously going this way. Here, what I did is, because this is straight, obviously, this angle ends up being 20 degrees up here. The other problem that, you know, so I don't know if that's kind of puts the ball at a weird angle, and, you know, this ball is obviously a lot more centered, so that's one issue. Another issue is, and it's going to be really hard to show this on the video, but the point is, even with this unit here, as short as it can possibly go, this piece right here this is a Pat's quick hitch, but this piece right here is still a lot lower than this one over here with the factory link. So this needs to be, you know, this height here, I need to take some of this up somehow without wrecking the geometry, so that this, you know, this arm down here comes up higher like it should. So, you know, a couple things to work through. I'm gonna kind of put the camera down here and mess with it a little bit and see if I can come up with a better design for this piece. But, you know, geometrically it does work. It sort of locates it the way it's supposed to be and everything, but a little bit more work to do. So I'll see what I can come up with and post again. All right, I think we might be onto something here. I decided just for the heck of it to try this 3D printed test piece upside down in the unit. And so what's happening here, number one, first of all, just to show you, so this is now number two is level with the factory fixed link, okay? And this is probably, I haven't measured it, but it's probably someplace midway in its travel, which is actually perfect. One was an arbitrary point I picked for some testing, and probably somewhere about where my finger is the absolute shortest this thing will go. So this gives you a nice adjustability up, and like I said, we're not at the bottom yet in terms of its travel either. So this would give you adjustability up and down, which is great. The thing we're running into here, and I think this is just sort of a redesign, not so much of a major problem, is, and you can actually see it, that where that gray looks like dust almost, it's not dust, that's actually this part, it's just plastic, it's 3D printed, right? So it's buckling because the arm here is hitting it, right? And it's causing it to bow all out and stuff. And the reason for that is it's simply too narrow back there, right? It's pushing on it because this is pulling in that way. When you raise this up, and you could probably see it in the video, but this whole unit rotates down and away from this arm. So it works when it's in the up position, but it needs to be a little bit wider for the lower position, and probably needs a little bit more clearance. But we don't have a clearance issue here, so this can actually come up a little bit longer to make this channel a little bit longer to sort of fit that. But I think this could be a pretty nice solution, just starting with the base part that I designed, and then I'll have to just work on how to make it easier to manufacture. I'm trying, you know, it'd be nice to get something that doesn't need to be machined, that I could just weld or whatever. But anyway, yeah, so I'm gonna mess with this a little bit. I might try another 3D printed part, a little bit longer, a little bit more clearance, whatever. We'll see what we come up with.